In this video, we'll deal with a thing called work that is closely related to energy. And it has a very simple definition. Here it is. Force exerted over distance. And the classic example is a person pushing something. Now, the object starts here and it's pushed for 30 meters. Can you see our distance then is 30 meters? And of course, that whole time, he's pushing with 120. So he's exerting that force over that 30 meters of distance. So our force is 120. What we're looking for is the amount of work done. Now, of course, this is a calculation, so I recommend a blue sheet format. Let's copy these down. Force is 120, distance is 30. What am I looking for? I'm looking for work. If you look out on the green sheet using these three things, you'll find that easy formula there. Then you simply substitute things in here, these numbers here, and you'll find that you have capital W, work, is 3,600 joules. Now, nothing could be easier than this, right? It really is easy, just plugging into a three-variable formula. And it's simple. Now, it gets a little more complex if you're talking about one particular force, and that's the force of weight. Let's remind ourselves about weight for a minute. This object here has mass, and the Earth's gravity is pulling it down, isn't it? We have a small formula for weight called W, little w now, equals at mass times gravity. So 40 times 10, now gravity, G is always 10. 40 times 10, we have a weight of 400 newtons down. The Earth is pulling this object down with a weight of 400 newtons. Now here's the trick. To lift this thing, this boy must exert exactly 400 newtons to lift it. If he exerts 200, it's not going to beat the 400. It's not going to lift, is it? 300, no. But just at 400, it begins to move up, doesn't it? So when you lift something, you're exerting a force equal to the weight. A weight is a force. The force of gravity is a downward force. And to lift, you must exert a force equal to the weight. Here's your video code. Again, when you lift something, you exert a force equal to the object's weight. All right, so the force up is 400 newtons, equal to the weight. I've given you a distance here. We're lifting at 1.5 meters. And now we're on easy street again, aren't we? Now that we realize that the force is the weight, we just plug it in. Force, distance, looking for weight, formula, substitute. Now our work is 600 joules. Okay? The only tricky part is that we have to know that weight is our force. To repeat here, when an object is lifted, the force exerted is equal to the weight of the object. It's exerted over a distance because you're lifting it, right, a certain distance, and so work is done in this formula here. How much work is done here? Let's see. Let's try this example. We have a 300 kilogram box, don't we? So we know when this forklift lifts this, the force is going to be equal to the weight. So let's find that object's weight. W equals mg for weight. 300 kilograms times 10. The weight of this thing is 3,000 newtons. Now we're on easy street. The force, 3,000 newtons. I give you the distance here of 4 meters. Work, plug it in. Work is 12,000 joules. And the only tricky part was you had to realize this is a lift. The force is equal to weight. That little calculation is required first. Then it's easy. All right, so in summary, we have two kinds of work, horizontal work and vertical work. Horizontal means pushing something along the floor, for instance. Force over distance couldn't be easier. Over here, on vertical work, you've got to do a quick side calculation. You first got to find the weight. In this case, 300 times 10. Then that's your force. Work is at 3,000 times the distance of 4. And we have our work for vertical. Horizontal work and vertical work. And vertical work requires you to do a side calculation to get weight first. Bye.